Hey, this is Bottom, and today we're going to be talking about game theory. And we're still in the theory of game theory. This is part 4. So last time we talked about maximally exploitative strategies. So recall that a maximally exploitative strategy it's a strategy against a fixed opponent. So that means that your opponent can't change the strategy, and you know their strategy. And so the maximally exploitative strategy against that strategy is the one that maximizes your EV. And the takeaway was, if you can, you want to be playing the maximally exploitative strategy against your opponent. Or a maximally exploitative strategy. They're not always unique. So one issue that comes up is your opponent also wants to be maximally exploiting you. So what happens? So this leads to a reasonably common situation called a Nash equilibrium. So I'm going to be defining Nash equilibrium. Nash equilibrium is a pair of strategies that maximally exploit each other. So this is a situation where both you and your opponent succeed in doing what you want to do, which is playing a maximally exploitative strategy. So how do these come up? So usually what happens is your opponent's playing a strategy, and then you play a maximally exploitative strategy against that. But then your opponent, the assumption was that your opponent fixes their strategy, and this, the opponents don't have to do this, right? They can change how they play as the game goes on. For example, if you play rock paper scissors over and over again against Bart, he may eventually learn that throwing rock every time is a bad idea. I mean, maybe not, but maybe so. And so what happens is that they might try to maximally exploit you, and because you're playing a fixed strategy, you're playing the maximally exploitative strategy against their first strategy, and then you'll try and maximally exploit that, and so on, and you generally go around in circles. So the Nash equilibrium is sort of a compromise. It's sort of, if you eventually end up at one strategy, it's going to be the Nash equilibrium, where you're both maximally exploiting each other. And this definition of a Nash equilibrium is maybe a little bit opaque. A pair of strategies that maximally exploit each other. You can't look at this and say, oh yeah, this is the Nash equilibrium for this game, right? I mean, even in rock paper scissors, you need to do a little bit of work. It's not totally obvious what the Nash equilibrium is in that game. So this definition, it's very useful to work with, but it doesn't give you a lot of intuition, unfortunately. So one way to get a little bit of intuition is to notice that if you're both maximally exploiting each other, neither of you can change your strategy and improve. And so that's an equivalent definition of the Nash equilibrium. It's a situation where neither of you can improve your expected value by changing strategies. And that's maybe a little bit more understandable. But this definition is good for working. There are going to be some proofs in the future, and we're going to use the fact that you're both maximally exploiting each other. And that's why we're going to define the Nash equilibrium this way. So this concept is really important. It's going to come up a lot. Generally, when you have a game, the first thing you're going to want to do is compute the Nash equilibrium, and we'll talk about how to actually compute the Nash equilibrium shortly, probably.